Hi and welcome to video 9 of this video series on annuities, and in this video from topic 1 unit 4 general mathematics we're going to be talking about perpetuities. There'll be a couple of videos here, a few examples, but the concept particularly compared to annuities is a fairly simple little add-on and hopefully will make sense here. So here I've got a graph of the standard withdrawal annuity. So you've seen this before, and so this is not a deposit-based annuity, but a withdrawal-based annuity or withdrawal phase. You'll see here that the annuity grows based on interest, but then it decreases because we withdraw money. And then it grows again based on interest, and then it decreases. Now, the hard bit here to understand, but what you need to think about is the fact that every time it decreases in this model that I'm showing you, it decreases to below the starting point, which means that in the next phase, we earn less interest. So eventually, the graph kind of gets steeper, and you can see I've tried to exemplify that here, where the graph will look a little bit like a quarter of a circle. It will just drop off, and eventually you'll just run out of money. So that's how that model works. But it's not the only model, and that's the thing. It's the most common model, and it's particularly common in the sort of superannuation sort of setting, where people they've saved a lot of money, they estimate how long they'll need it for, and then they live off that and have it run out at zero. But we do have some other options. So for example, what if we withdrew less money than the interest? So I've got a little table here. What if we withdrew less money than interest as this one here? Well, if withdrawals are less than interest, then obviously it's going to continue to grow. It's actually going to be a growth model. Won't grow as much as the deposit phase, but it will grow over time because we're earning interest, then withdrawing just part of that interest, which means overall we've got more in the account. So it will never run out, which means that you can live forever. There's a little clause there though that you might want to read. And if the withdrawals are greater than interest, this is a standard one, then we get a standard annuity, and it will decrease in value and the money will eventually run out. But if we can get the withdrawals close to the interest, the money will last a long time. Then, what if we have the withdrawals equal to the interest? So this will neither grow nor decrease. It will last forever, but without growing. And it's called a perpetuity. So that's what we're looking at in this exercise, and it's a context that may come up in your external exam. So let's have a look at an example. I have $70,000 saved in an account earning 5.2% per annum, compounding monthly. How much can I withdraw at the end of each month such that my investment remains steady? So in this case, what we really want to know is how much interest do I earn each month, because that will tell me how much I can then take off so I end up back at $70,000. This word here, steady, it's not the best mathematical term for it, but it's really common, that consistency, that remaining steady. Look for those key words that are going to tell you what's being asked to do. So in this case, we're working towards steady, and we're going to compound this 1 month and work out how much 1 month of interest is. So basically we're going to look at, if we're looking at the recursion model, we just want to know what A2 is equal to, and it's equal to A1 times by 1 plus I. And that will tell us how much we now have. You will know this formula, A equals P, 1 plus I to the power of n. It's just we want to know what 1 month is, and so therefore n is equal to 1. Now if I do this calculation with the numbers I've got, A1 is $70,000, that's what I start with, times by 1 plus I, which is 5.2%, but divided by 1200. 100 for the fact it's a percentage, I want to turn it to a decimal, and 12 because it's a monthly rate. And then I get a value. Now that value is $70,303.33, and the 3 is going forever here. Okay, so there's my total value, but that's not the interest earned. To determine the interest, I would have to do the amount that I gained, A2 minus A1, which is equal to $303.33. Now I wanted to link this back to compound interest, which is a part of the formula has been using, but of course you might recognize here there's actually just a simple case of A2 is equal to the interest rate I times A1, and we're not going to use A2 anymore, we're going to use interest because we want to determine interest. So the interest is equal to the interest rate I times by A1. And if I do that calculation, which is 5.2 over 1200 times by A1, which is of course 70,000, that will just tell me how much interest I earned, which is 303. So I'm going to lead you towards a formula here, but ultimately it's good to have that background understanding, and we could skip straight to here if we've got a deep understanding. If we don't, we might do it this way, which works out just as well and doesn't take that much longer. So it doesn't really matter how we approach this. Anyway, I can withdraw $303.33 per month. Now, part B said, how much can I withdraw at the end of each year? So this is slightly different, and this does now come back to this original model that I asked you to think about. So for this to maintain as a perpetuity, each month they can withdraw $303.33, which in total, if I take it out each month, is actually $3,640. That's just 12 times $303.33, and so that's the total I can take out over a year. But this part B is asking me, how much can I withdraw at the end of each year? So it's not implying that it's a monthly withdrawal to get to the end. It's implying that I'm withdrawing a total at the end of the year only. So what I need to think now is, how much interest do I earn over a year? So I go to part B and I think, I want to calculate A12. And in this case, A12, which will be 12 months worth of interest, is going to be P times 1 plus I to the power of 12. So I'm back to this formula up here, the compound interest formula. How much interest do I earn over the year? And keep in mind, this is not an annuity at the moment, because there's no suggestion that I'm withdrawing anything else. I'm only going to withdraw at the end of the year, nor am I depositing. So it's just a compound interest question. So now I can work out my A12. That's 70,000, my original amount, times by 1 plus all this stuff. You get a bit sick of writing all these numbers, but that's all right, to the power of 12. And if I do that calculation with those values in, it gives me 73,728.02. And of course that's a rounded value, but 02 because we're talking decimal and money, so we go to 2 decimal places, and we're finishing now, so I don't have to give you any more detail. But you'll notice here that I have maintained that decimal, which is the perfect value, the most accurate value in my calculations. Now that's the total I have after 12 months. So therefore my interest earned is equal to 70,000 taken away from that, which is 3,728.02. So if I keep my money in there for a whole year and it's earning money per month, but I don't take out money till the end of the year, then I actually earn $3,728.02, which hopefully you can see is actually a bit better than if I took money out each month over a year. So comparatively, if we leave the money in there for a year, the money that we would have taken out is earning a little bit more interest, so it's a little bit better. And in this case, almost $100 better. Now, sounds perfect, doesn't it? Why don't we all just set up perpetuities? We do have to be a bit careful because there's this thing called inflation. And inflation is a number that describes how, in general, or on average, how much the economy has grown. So it tells you on average how much things have risen in price. It's an average of everything. So if you go down to buy milk, it may not have risen in price at all, but overall, the cost of living, what we have to pay as consumers, has gone up. And inflation is typically in what they would deem worse years, about 1.5, but it can get up to 2.53. So, and that's a percentage growth. So that means that if we had a perpetuity we wanted to live off for 50 years, then we might have a lot of money coming in each month now, but that money won't be worth as much later on, because the price of milk will have gone up by, on average, 1.5 or 2% per year every year for 50 years. And so all of a sudden our money is not going as far. So we have to be a little bit careful with perpetuities. Sometimes it's better to try and make it a perpetuity where you're actually taking 80% of the interest instead of 100% of the interest, and so your money is still growing. And so we're back to this original model here in pink. We want the withdrawals to be a little bit less than the interest, but that's a bit more of a complex calculation that we need to consider. So I'll leave it there for this video. All the best.